Hello students, this video is brought to you by Sadan Pathshala. Now MCQs on chapter atoms. Who proposed the plum pudding model of atom, that is J.J. Thomson. Planetary model of the atom was proposed by Rutherford. Thomson plum pudding model of the atom was discarded because the model failed to explain the result of Rutherford's alpha scattering experiment. In alpha scattering experiment, it is found that most of the alpha particles scattered at small angles and very few deflected backwards. Okay. Fifth one, the Rutherford alpha particle experiment. Alpha particles were bombarded towards the gold foil because gold nucleus is much heavier than the alpha nucleus, and also gold is highly malleable and can be drawn into very thin sheet. Therefore, both the options are correct. Therefore, both A and B are correct. In Rutherford alpha scattering experiment, distance of closest approach is, that is 10 to the power of minus 15 meter. Inside the nucleus of an atom, almost the mass of the atom is concentrated. Entire positive charge also distributed. Nuclear forces exist. Therefore, all are the correct answer. Perpendicular distance between the initial velocity direction of the alpha particles and the center of the nucleus is called as impact parameter. If you consider this as the gold nucleus, and this will be the line passing through the center of the gold nucleus, and this is the initial line of the alpha particles. The perpendicular distance between center of the nucleus and the initial velocity, it is called as impact parameter. In Rutherford's alpha scattering experiment, when impact parameter is 0, impact parameter is 0 for head-on collision. Head-on collision means that is theta is equal to 180 degree. Okay, therefore it is limited. According to classical electromagnetic theory, path of the electron orbit in a nucleus is, that is spiral. Okay, next question number 11. Question number 11. According to Rutherford model, nucleus of an atom is positively charged. According to Rutherford model, centripetal force of the electron moving around the nucleus is provided by the electrostatic force. Okay, electrostatic force of attraction between positively charged nucleus and the negatively charged electrons. When an electron revolves around the nucleus, its electrostatic potential energy is negative, kinetic energy is positive. We know that potential energy is equal to minus z squared divided by 4 pi epsilon naught r. Kinetic energy is equal to z squared divided by 8 pi epsilon naught r. Rutherford nuclear atom model failed to explain the stability of the atom. According to Bohr's postulate, angular momentum of the electron in orbital is equal to integral multiple of h by 2 pi. That is second postulate, L is equal to nh by 2 pi. According to Bohr's hydrogen model, the radius of nth orbit is given by r is equal to n square h square epsilon naught pi m z square. That is r is directly proportional to n square. That is option D. According to Bohr's hydrogen model, the radius of first, second and third orbit. So according to this relation, r is proportional to n square. That is r1 is to r2 is to r3. That is 1 square, 2 square, 3 square. It is 1 is to 4 is to 9. That is option B will be the correct one. According to Bohr's hydrogen atomic model, as long as the electron moves in a stationary orbit, electron does not lose energy. That is the first postulate of the Bohr. According to Bohr's hydrogen atom, as electron move in outer orbits, speed of the electron decreases. Okay, speed decreases as the n increases. It is orbital velocity of the electron in the nth orbit is given by V is equal to E squared divided by 2 epsilon naught n into h. As n increases, V decreases. That is given in question number 19. Question number 21. Radius of the first orbit of hydrogen atom, it is nothing but 0.53 or 0.529 angstrom. Okay, that is a option E. Total energy of the electron revolving in a stationary orbit around the hydrogen, that is given by En is equal to minus 13.6 divided by n square electron. That is always negative. Negative sign indicates that electron is always bound to the nucleus and you need the energy to remove. Energy of the electron in the ground state of the atom. Ground state means n is equal to 1. Then you are getting minus 13.6 electron volt. Minimum energy required to remove the electron from the ground state of atom is called as ionization energy. The ionization energy of hydrogen atom is, that must be 13.6 electron volt. This much energy is needed to remove the electron from the ground state. According to Bohr's hydrogen model, as the electron move in outer orbits, its total energy increases. That is, from the relation, if you have En is directly proportional to, okay, that is directly proportional to 1 divided by n square. As negative sign is there, as n increases, energy also increases. According to Bohr's hydrogen atom, the total energy of the electron in the nth orbit, it is proportional to 1 divided by n square. The series of hydrogen spectrum lying in visible region is Balmer series. Lyman series of hydrogen atom lies in ultraviolet region. Energy required to excite an electron from lower energy state to higher energy region is called as excitation energy. Value of Rydberg constant, that is R, is equal to 1.097 into 10 to the power of 7 per meter. SI unit of wave number is per meter. If N1 and N2 are represent quantum numbers of lower and higher energy states respectively, then the first line of Lyman series. Lyman series means N1 is equal to 1, N2 is equal to 2. Therefore, option B. If N1 and N2 represent quantum numbers of lower and higher energy state respectively, then second line of Balmer series. Balmer means N is equal to 2. Second line means, so N is equal to 4. Therefore, N1 is equal to 2 and N2 is equal to 4. If N1 and N2 represent quantum numbers of lower and higher energy state respectively, for Paschen series means N1 is equal to 3 and N2 is equal to infinity. Okay, they are asking the first line, the last line of the Paschen series. Therefore, last line will be N2 is equal to infinity. If N1, N2 are the quantum numbers, so then what is the first line of bracket series? That is, bracket series is the fourth line. N1 is equal to 4 and N2 is equal to 5. Different lines of different series of hydrogen spectrum will be obtained when electron from higher orbit undergo transition to the lower orbit. That is nothing but it belongs to fifth series. Therefore, N1 is equal to 5. The formula for the wave number of Paschen series is given. That is, Paschen series given by 1 divided by lambda is equal to R into Paschen means N is equal to 5. Therefore, 1 divided by 5 square minus 1 divided by N square. Bohr's hydrogen atom fails in explaining the intensity of the different spectral lines of hydrogen atom. Bohr's hydrogen atom model successfully explain wavelength of different series of spectral series. Thank you. Please subscribe Southern Pathshala for more such videos.